Hello everyone, welcome to the afternoon session. We are having a talk by Jonathan on building a personal home automation setup. Over to you, Jonathan.
Yeah, so I'm gonna start with a warning or apology. It says home automation. It's really about yak shaving. I'm gonna talk about privacy. I'm gonna talk about Debian. I'm gonna talk about hardware, and I promise it's got home automation at the core, but I'm gonna go into a whole bunch of tangents. Um, as part of that, my primary motivation whenever I started looking at home automation was I'd moved house. And I moved house to, I'd had a 7-day heating timer in my previous house, and I moved to a new one that had a 24-hour heating timer, and it turned out that I actually really quite liked that because it meant that the heating came on later at the weekends than it did during the week. And I was like, right, I need to fix that. And the easy option would have been to go and replace my heating timer, and I thought, no, I'll do something, I'll get something cleverer. And there's lots of sort of things out there in terms of like the Nest or Hive that will do heating control and be sort of smart about it and learn your movements and let you control it remotely. And they all sort of sounded quite neat, but I wanted full control myself. I didn't want the ability for an external provider to decide they're going to turn me off. I know that Google have turned off some of the Nest functionality. I didn't want any of those external dependencies. I didn't want my heating to require an internet connection, otherwise it wouldn't work. So I wanted something that was self-contained and something I had full control of and something I understood all the pieces of. I also had other home occupiers to consider. It wasn't like I could just build this for mine. I've got a friend who about 15 years ago did home automation for his heating system. And what he has is a PIC chip which is attached to his gas boiler and then has a serial connection to the home gateway that lives in his attic. And he's done a whole bunch of complicated code about hysteresis and trying to ensure a constant temperature and backing off and maintaining that temperature, only firing up when he needs to. And his wife hates it because she doesn't want to have to SSH to the machine in the attic in order to tell it what temperature to be, sometimes involving hex digits. So, other people needed to be able to use this. There was no point in me building a home automation system that was me SSHing in and running some Python or something. I also had no desire to do serious home alterations. While I'm happy doing sort of little bits of fiddling here and there, I didn't really want to have to do stuff. The house I moved into had been reasonably recently refurbished, not run wires though. Like for some reason they put coax to every room, but there's no Cat5 to every room. There wasn't even a phone socket in the house when I moved in, so weird set of priorities, but I wasn't ripping all of that out to suddenly do rewiring. So I wanted to work within the constraints of what I had without sort of requiring too much DIY. I've built a bunch of bits and pieces around it, but nothing has been particularly major. So I started out and it's like, right, I'm going to do some home automation. Where do I start with that? So I found a thing called Home Assistant. And Home Assistant is this excellent piece of Python home automation software. That's their website, they're on GitHub, they have a bunch of options available. The big one they push is Has.io, which is I think a Raspberry Pi, Raspberry-based thing within the sort of Home Assistant software sitting on top. I already had a house server, so I put it in a systemd container under Debian. And I know we hate on systemd, and I know that there's been big flame wars about it, but see systemd nspawn? Systemd nspawn is awesome for firing up lightweight containers. Like, it's already on your system. It sort of does this communication thing with systemd outside and systemd inside, so you can do some monitoring. It doesn't get in your way. Like, I installed Docker, and Docker takes over my networking, and it's like, I don't want you to touch my networking. This machine does other things. So I'm a big believer in firing up containers for things under systemd, and I just Debian install within it. It's currently Stretch, because this is my home automation. I was running it on top of Stable. I'm going to move it to Buster relatively soon, but just before I went to DebConf, didn't seem like the right time to do that. Home Assistant has a fairly fast release cycle. Like, they're releasing at least once a month, and they do point releases a bit more often, which means that I've ended up having to run it inside a PyEnv. So it's a Debian base install. It's got base Python 3.5 installed, and then I use Ansible to actually deploy, and a PyEnv thing there. This is one of the problems I think we have in Debian, is that this pulls in a bunch of Python modules, and some of them are actually in even Stretch, and there's a lot more of them in Buster that will be satisfied. And I've sort of looked, they are pulling up-to-date versions of lots of things for talking to home automation software, but there's no easy way for me to tell the virtual environment that I wanted to pull everything it can from Debian where possible, and then only pull in those bits that it can't get from Debian into the virtual env. And this is something we've seen with sort of like the Node ecosystem. It's something that even existed before with Perl. We need to get better as a project about how we integrate these third-party language package managers into the whole system as a whole. Like I don't want to have two entirely different things that don't understand each other. I'd rather try and satisfy from Debian. I trust Debian developers to do a much better curation job of how the package ends up, of pulling in minor point releases for security updates, for making things work together, than I trust language authors who, I mean, I have code on PyPy and I'm no excellent Python programmer. You can shove it up there and they just let you upload. I didn't have to get a key signed by anyone. There were no complicated questions about how I got something on PyPy. So this is something we can do better. That having said that, Ansible, systemd, nspawn, Debian as a base, all beautiful things, and it all just works. I should also say that the Home Assistant folk are actually quite open to contributions. I've actually contributed a few minor bits and pieces back to them, and they do GitHub pull requests. They've got contributors agreement, whatever, and actually the project as a whole seems to work quite well, and I'm quite impressed by that. But just this cutting edge stuff, it's like there's this tension between I want a stable release for the thing that's running my home automation software, but they're not doing security releases. They're just, it's one steady stream of releases. They're not at 1.0 yet, so maybe when they get to 1.0 it will be a bit better, but that's that. So I had that was my control software. It was going to run on the thing, and I had it up and running. This is what it looks like on my phone. I then wanted things to be able to talk to it. And what I ended up with is a thing called MQTT. Someone told me about this 5 years ago, and I'm like, no, that's a silly idea, that's stupid. And then whenever I actually came to look at it, this is actually a really great idea. This is a lightweight message broker. So I can never remember what the TT stands for. It's message queue transport something or other. It lets me decouple my sensors from my control plane. So Home Assistant talks to the MQTT server, and then all of the sensors talk to the MQTT server, and that means that it doesn't matter where everything is or what's up or what's not up. The sensors can always talk to the central server, and the Home Assistant can always talk to it. And if things appear or disappear, the broker concerns itself with that. The one I settled on is called Mosquito. It's in Debian. I happen to run it on OpenWRT because the OpenWRT router sits at the center of my network. I have a split network where I have a media LAN, a trusted LAN, and the Wi-Fi, rather than just bridging everything. And it sort of got too complicated trying to forward all of that to the Home Assistant server, and this sits in the middle and fine. I've also done proper SSL cert. If we're going to do IoT, I'm going to do it right. I'm going to do encrypted end-to-end points even though it's within my house. I'm going to do it with proper certs. I know this works because when I forget to renew the Let's Encrypt cert, my house stops talking to each other, and I have to go, oh yeah, I forgot to push the cert to the router. I need to automate that better, but I haven't got that yet. And just to, let's see if I can, is this going to work? Right, so, I can find out what the mouse is. So this is running on server in my house, and this is what MQTT looks like. I'm not sure I can. There we go. So these are last will and testaments that are telling you all of these devices are actually on. This is saying that there's someone in the house. I'll get to that later. And then these are specially formatted messages that Collecti understands. That's sort of doing temperature and humidity and pressure, and you can see my server is currently using 41 watts. And then it sort of get these periodic messages about the actual state. So this has been up for 67 days, and it's on Wi-Fi channel 1 and all of that stuff. So this is really simple to deal with. You basically publish a text message to a path, and it's easy to debug. You can sit and watch these things, and it's like, this is actually just under the hood running Mosquito sub. It's a single command that then dumps this out. There's nothing complicated there. The only reason I didn't type it is because it's then got a password in it to talk to the MQTT server, and I didn't want to put my password on a stream for some reason. But yeah, so that's like really easy to sort of deal with. So you've got this really lightweight thing that you can talk to from, there's like, and I'll get to this in a minute, there are lots of things that will talk to the MQTT server, and then you can basically plumb in the Home Assistant stuff with it, which is really quite nice. Just get back to that, right? So that's the sort of connection point. I had the control plane, I had a sort of message passing thing. I needed actually to put something on it. The logical first thing, let's put a sensor on it. So, of course, I used a Pi. This is actually an original Pi. It's like retro. It's like 256 megs of RAM, and I have nothing better to do with it except have a very expensive temperature monitor. So, this thing here is a BME 280, which you can buy for like a couple of bucks off eBay. And it's an I2C sensor that does temperature, humidity, and pressure. And it's literally plugged directly into the pin headers on the Pi. There's no soldering required here. It's like, hey, I can do electronics. I plug the module in. And that code will actually do the temperature thing. That will publish to the MQTT host. It will publish to location study temperature as the thing, and it will read the I2C stuff because the Linux kernel has the driver for it. I mean, this is easy. I mean, there's obviously some extra error checking around it, and I've got the humidity and pressure being done as well. But you know, all of a sudden I had some data. Like I was actually able to graph the temperature in my study. This is still sitting on my study floor. I haven't got around to actually doing anything better there. But so it's sitting on my study floor, and then it's like, well, actually, the temperature of my study isn't really the important thing when I'm controlling my heating. What I care about a bit more is the temperature in the living room. And I'm like, well, I've got a media box that's always on in the living room. There's got to be something I can plug into that. And there's an off-the-shelf device called a Temper USB, which various people have used. And it's sort of like this little USB stick. I'm like, I'll buy one of those. It's like $10, that's fine. And then because I like to shave yaks, I realized I had all the bits I needed to build my own or whatever. So this is an AT Tiny 85. It's a DigiSpark board, which is basically really, really evil in that someone's written some assembly to do bit banging of the GPIO pins so it looks like a low-speed USB device, and it's beautifully evil, and it's entirely free software, and you can just download this handcrafted assembly that does the timing just right. And then the thing that's sticking out of it is this is a one-wire temperature sensor, so it's a DS18B20, and they're really easy to talk to. I have now implemented code for one of these on various different platforms because it seems every time I have an embedded platform I want to do a one-wire temperature sensor. It's what I do. I'm not sure that's a marketable skill, but it's kind of fun. So yeah, so I built this, and I had this USB assembly stuff that's actually GPL'd, and then I wrote some stuff around it, and it's really nice because the toolchain's entirely in Debian, AVR GCC, the AVR libc. You can build, this is running entirely free firmware that I built entirely using Debian main. So yeah, she had another yak. So I had another temperature sensor, and this one's only doing temperature, but it actually, I've moved away from this for various reasons, but it did actually 9 months plus of monitoring the temperature in my living room and feeding that into the rest of the control system. And then it's like, right, well, you know, I've got 2 temperature sensors, let's have another one. So this is a Xiaomi Bluetooth low energy sensor, and the nice thing about it is it takes a single AA battery, and again, this is sort of under $10. I've been doing home automation and kind of ignoring how much my time costs and buying lots of very cheap components, and let's not think about the actual cost of all of this because it's kind of been entertaining. But this is standalone. It therefore was ideal for my bathroom, so it's stuck to the side of my bathroom cabinet. It means I can monitor the temperature and humidity there. It does broadcast over Bluetooth, and if you look at all of the code that's out there for it, like Home Assistant has a driver to directly talk to it. It deliberately goes out and says, hey, what temperature is it? And it turns out the device is actually just every 2 seconds going, I don't know who's out there, but here's the temperature. So it broadcasts that every 2 seconds, and that's actually less power because it doesn't have to do a full Bluetooth handshake. It just literally does the broadcast. So you get faster responses, and you use less power by simply listening for it rather than explicitly querying it. And that was quite neat. So I learned some Go because, hey, I had to do something new as part of this. And that was actually my first experience of Go. And again, to tie this back to Debian, some of it was nice in that I did run Go from Debian, and some of the things I hate about Go in terms of it pulling stuff in and being statically linked really turned out to be quite useful in this thing because my development box is different than my server box, so at the end of it I got a Go static binary that I copied over, and it just worked, and that was nice. And I didn't have to worry about copying all the right libraries over, but on the other hand, I just don't trust compilers that deliberately go and fetch things from the internet for me to compile. And some of the stuff, so the Go MQTT is in Debian already. The Go Bluetooth stuff was not in Debian because it's sort of an esoteric package. So it's sort of pulling it down. It was very easy from a development point of view, but I just, again, it comes back to how do we solve these language-specific problems within Debian in a way that ties into the Debian ethos and gives us all of those good things from Debian, but doesn't just make anyone who uses the language go, well, I'm not touching any of the Debian stuff because it just gets in my way. So I don't know, but I don't hate Go as much as I thought. There were some advantages. So I've got 3 sets of sensors, and that's a good lead into, well, what does sensors tell you? So we've got all this information and recording it. This is stuff that people are sending to the cloud. If you've got a Hive or a Nest, it's going to the cloud, and someone's analyzing your data, and you know they're analyzing it. Does anyone want to guess if I tell you that the graph on the left is the humidity in my bathroom when the 2 adult occupants of the house had a shower? Because that's fairly clear. And if you look at the right-hand one, not quite as clear, but does anyone want to tell this is the temperature in my kitchen when we made dinner? I mean, it's where the temperature goes up. And I've seen on the living room sensor, I don't actually have it recorded in a graph, otherwise I'd show it as well, but in the winter, I could tell when the front door opened. The living room is beside the front door, and there was just this little dip for like a minute or two, and it was like very obvious, and you're sort of going, is that an artifact? And no, that's when I went to work. And that's just from like a cheap-ass sensor that I built that's doing a sensor reading once a minute rather than as often as it can. So this sort of convinced me that I was doing the right thing by building this myself and not sending the data elsewhere. And it gets into sort of more worrying stuff whenever you get to presence awareness. So I had temperature monitoring of the house. The other thing that I thought would be a neat addition to add in over and above what the temperature is there anyone in the house? GPS tracking is too invasive. I had a conversation about this with my wife, and she's like, that seems a bit weird and creepy. And I was like, yeah, it does, doesn't it? And so we decided not to do the thing where your phone says, hey, I'm coming home from work. But instead, the useful proxy was phone Wi-Fi. If my phone or her phone is on the Wi-Fi in the house, then it means one of us is home. And that's, that's usually the case. Now, Home Assistant can scrape the Lucy web interface for OpenWRT. It'll basically go in and go, hey, what have you got on your ARP table, and do that, and that works, and that would have been the easy option. But as I started out with, this is a yak shaving talk, so I used it as an excuse to learn about netlink. So the Linux kernel netlink interface will proactively tell you when it sees an ARP request. And I then tied that into a piece of code that watches for that netlink message and then sends an MQTT message saying, hey, I've seen this device arrive. And that means that as soon as the device is seen, there's a notification to Home Assistant that the device has appeared. So there's no latency when you arrive. There's a little bit of a latency about falling off at the end because it's sort of a case of it goes, hey, I haven't seen a device for 10 or 15 minutes. It's in an unknown location. And that's the right way around. We want the heat to come on as soon as possible whenever we come home, but we don't mind about staying on a little bit whenever we leave. And that's worked quite well. Now, the downside of this is, and these are sort of failure modes you suddenly have to think about when you get into the home automation. My Wi-Fi access point upstairs is connected to the downstairs router via power over Ethernet. Running a cable is on my list of things to do. I've got a lengthy list of things to do. The power over Ethernet sort of about every 3 months falls over in a way that it can't talk to each other, and it's just a case that you have to reboot the power over Ethernet adapters, and that's not, it's annoying, but it's not frequent enough that I've got around to running the cable. However, if the Wi-Fi access point loses connectivity to downstairs in the middle of the night, and your phone in the bedroom is connected to the upstairs access point, in the morning when the heat's supposed to come on, it doesn't think there's anyone in because you're associated with the upstairs access point, and the thing that's doing the monitoring is downstairs. And thankfully this happened sort of in spring and it wasn't cold in the morning, but there was a point of, oh yeah, that's a failure mode I hadn't considered. So all of a sudden you've made this sort of reasonably simple home heating system that worked just fine a little bit more complicated, and you've got to think about that. But as I say, it's not too much of a problem in my case, but it was sort of an eye-opener about, oh yeah, I've got to think about that one. So I got the temperature sensor, I've got some notification about whether I'm in the house or not. The next thing to do was obviously actually control the heating. I'm not big on playing with mains power. It scares me. Not as much as water. Water seems to get everywhere, but mains power is sort of a scary thing. Thankfully, my home heating system already had a wireless sensor that was actually the thing that controlled it, and then there was a box on the wall that received the signal, and it turned out to be a 433 megahertz transmitter, which is an openly licensed area of the spectrum, and lots of things use it. Someone else had already worked out what the actual protocol was. It's basically you turn on and off the signal for about 32 bits of data, and that has a code embedded with it, as well as an on-off. And there is a commercial option called the Broadlink RM Pro that will actually do this for you, but hey, yak shaving, I'm going to build my own. Again, I had an AT Tiny. I bought like a bunch of these, and they're therefore my go-to whenever I need something small. And the thing beside it is like a $1 433 megahertz transmitter, again off eBay, and I think I did have to solder the pin headers on it, but there's no complexity there, and that just looks like a USB device. So you plug it in and it looks like a USB device that controls a relay and lets me turn it on and on. So that ended up plugged into one of the PCs and having an MQT thing to control it, and those are those bits, and all of that ends up looking like, if I can get to it. So I built a Home Assistant thing that, this is actually live from my house, forwarded over SSH. I built a weekday and weekend timer because I don't really care about actually changing it every day. And you can see that the living room is currently 22 degrees and it's in idle mode, so it's like target is 5. This is showing you the actual target heating temperature, and then this is the temperature of various rooms around the house. So it's actually for once warm in Northern Ireland. If I give this talk, in 6 months' time you'd find the heating was constantly on and never turned itself off. But that's not bad. I mean, that's easy, and it's easy enough to go in and you can basically force the boiler on or force the timer on there, and it's, you know, this works on our mobile phones, so we both can go in and do this. The other piece about sort of things you don't think about is that I put my wife's phone and my phone on it, and if we leave the house, the heating goes off, and that means that if her parents are there minding our kid, the heating goes off when we leave. So now I had to add one of our parents' phones as well to make sure that the heating didn't go off. I mean, I could, the way it works is it's all about triggers, so it's when an event changes, so I can actually leave the house and turn the heat on, and because the phone won't then leave the house, the heat stays on, but that means I have to remember to do that, whereas it's much easier if you just let someone have control. So that's the heating, and that's sort of the key bit of what I wanted to get done. I had this heating system that actually was better, and this has been in operation. I managed to get it all in operation about September last year, just before it actually gets to the point that the heating needs to be on, really, in Northern Ireland. And then we went on holiday for a week, and because we weren't there, the heating didn't turn on, and we got back to the airport at midnight, and I was able to log in from my phone and turn the heating on, and that meant by the time we got home, the house was warm, and I considered that an overall win. But of course I wasn't done there, because I have more bits and pieces lying around the house, and I'd love to say I have more spare time than I should, but I really don't. So lights are the next thing. Lights are the obvious thing, and I sort of wanted to be able to turn lights on. Again, we're looking at mains. So there's a bunch of off-the-shelf devices that will do this Wi-Fi controlling of your stuff. Unfortunately, in terms of free software, none of them are very easily upgraded without having to take them apart and sort of solder onto pin headers. And it's not, most of the time it's not particularly complex. It is the few pin headers, a serial connection to it, reflash the firmware, and you're done, but it is a trying to get into it thing. There's a project called Sonoff Tasmota that's on GitHub and is Arduino based and talks to most of these and has support for like all manner of the devices you can buy off Amazon or eBay. I ended up writing my own. And the reason I ended up writing my own was largely because I really cared about doing the TLS properly, and these devices have a very small amount of memory. So if you use the Arduino, you end up with a bigger stack sitting in there, which means that when you go and try and do TLS verification, there's not enough space to do the full certs and everything like that. So the firmware I have has an embedded Let's Encrypt CA cert in it. So it's actually doing full TLS validation of the fact that the MQTT server that it's connecting to has a cert that's issued by Let's Encrypt, and it's doing NTP before it ever does that. So it's never doing, it's checking for expired certs as well. So I kind of feel that, I mean, it's a little bit of over engineering, but I feel that if I can do this in my house, then IoT manufacturers should really be able to do this on commercial products that they're selling. The toolchain is now part of Buster. I actually learned how to do cross-compiling of stuff with GCC and applied the patches and got this in upstream, and Keith Packard was very helpful last DebConf with me about how to actually do that. Unfortunately, the overall firmware has a whole bunch of free software in it, things like the LWIP IP stack, the libc is newlib, the Wi-Fi stuff is a big binary blob. So unfortunately you can't build a fully free firmware for this. It's close, but it's not entirely there. But you can build on it on Debian, and it's the Extensa who make the ESP8266 core CPU piece are quite good about pushing their stuff upstream for both bin utils and GCC, so at least it's supported there. So that was good. I had light control, and then this is the bit that I always get in trouble for on Twitter. There's always like one or two people who go on Twitter, hey, this nullifies the entire thing, you've got an Alexa in there. And there's a point, yeah, they do. I had one already. I'm not sure that makes it any better, but I did have it already. And I was worried about privacy even before I ever plugged an Alexa into my network. But don't put it anywhere sensitive in my house. It lives in the dining room. It mostly gets shouted at in order to provide us with music. Home Assistant has good logging about actually the requests that come in, so every single time the Alexa is used to turn a light on or off in the house, I have a log within the Home Assistant that actually says what's going on there. The way in which the traffic comes into the house is coming through HTTPS proxy, so I have logging there, and there's no information actively going out, so the things like the temperature sensors aren't being fed out to Amazon. And in terms of usability, having it possible for guests to your house come in and be able to say, turn on the lights, is really useful. Now I hope at some point we'll have something that will use the speech recognition that's being worked on by Mozilla, and this will all be done entirely in the house, and it'll be possible. But for now, like Home Assistant has support for this. I had one already. I've already risked Amazon listening to all my conversations, so it was quite nice to tie it in. As I say, people turn up and it's like a really easy to use interface. People know what to do. They like come in. Mostly people try and order things from me in the Alexa. Like the first time a friend met my Alexa, they tried to order me gin, which was nice of them, but I turned that functionality off. So that's the only piece that requires external access, and everything works just fine if that's not in operation, if the external access isn't there. There's nothing else that I'm discussing in this talk that requires an internet connection or sends any data, receives any data from the outside world. But there is that piece, and if you think less of me, well, I'll take that. The next bit's the doorbell. And I put this picture up to annoy John, because this is how bad I am at electronics and wires and things. I couldn't hear the doorbell throughout the house, particularly in my study on the top floor, sort of out of the way. I just couldn't hear the doorbell. And it's a 433 megahertz device, same as the central heating, except that it's a slightly different protocol, but they're all on off. Like literally all you got to do is figure out the timings for the on and off bits, and then do a loop to turn them on and off. It's quite easy overall. And I ended up, I couldn't get the timings quite right on the transmitter, so this is actually the original doorbell board, and then this is a tiny ESP8266, and I've just tapped a wire off where the doorbell actually toggles the speaker. It's a terrible, terrible hack, and I don't recommend anyone does this, but it does work. And it does notification via the Alexa, so you can do a chime on the Alexa, and it can make a speaker ring or whatever as well. And you sort of go, I mean, I originally did this for fun. It was kind of like, it'd be nice to hear it upstairs. And then the day after I did this, we were sitting having lunch, and the door was closed or something, whatever it was. We didn't actually hear the doorbell, but we heard Alexa chime. And I'm like, is that broken? You know, have I done something wrong? And it was actually someone at the door, and it was a delivery for my wife, and we wouldn't have heard it otherwise. And instantly I had brownie points for the fact that I'd done something useful that was just a hack that turned out to actually be really beneficial to us in terms of knowing that there was someone on the door not missing that parcel. And that's one of the things that sort of got me about the home automation stuff. A lot of the stuff I've done has had sort of surprising, hang on a minute, that's quite nice, I can do that now. And in particular, that this is my favorite home automation example. The picture doesn't look particularly great on the board. So this is what we call the cinema room, and I promise you it looks better these days. It does actually have a proper sofa in it, but if you can't quite see, these are 2 deck chairs, and this is actually a beer fermenting barrel and a tiny pico projector, and this is just a white wall. And this is a junk room that we ended up going, hey, we've got some stuff when we put it in. But the pico projector only works in really low light. Like, it's a 720p projector, it's a lovely little device, but you turn the lights on, if there's any light in the room, it just gets washed out because it's such a small LED bulb in it. And the room only has one small window. But the box that was connected to it was a Kodi box. The lights at the back of the room are actually on. We're on home automation already. And so you hit play on the Kodi box and the lights go out. And you hit pause on the Kodi box and the lights come back on. And that's just a very simple thing that was, I suddenly had to piece together, and that was tied together. And then the other thing was that this is a room we don't use very often. I mean, we've got a TV in the main room. This is a sort of a special occasion, once a week at most thing. And I would turn the heating on the radiator, and then I would forget to turn it off afterwards because the room isn't generally used. So now there's a Bluetooth radiator valve on there, and there's a button on the Home Assistant that does activate. And activate does a wake on LAN for the Kodi box, turns on the lights, tells the radiator to turn the heating up, and then you're good to go. Oh, and turns on the projector and everything. They're all on one of the switches, the ESP switches. And then when you're done, when you turn the lights off at the end, if the AV equipment has already been powered down, it assumes you're done in the room and turns the radiator off as well. And that's just an unexpected, hang on, I've got all these things connected up and I can tie them together. And that was quite cool, I thought. And then more lights. So yeah, sometimes you don't realize what can be useful. You've got these bits lying around, and until someone says, I wonder if we could do, you don't realize that there's something you can easily do. And in particular, what had happened was we had our first child, and turning on the lights at night away from the bed so that it was dim enough that the kid wouldn't wake up, but enough to see light. And it was like, well, hang on a minute, I've got a spare socket, I can plug that light in, and all of a sudden we have the ability to remotely control the light that's away from the bed without us having to go all the way over the room in the dark and trip over things and potentially cause things. And then there was more about these. These are LED strips that you can, again, buy cheaply online. And this is actually the top of a wardrobe that happens to have an edge around it. And this gives me a nice uplighter effect. And again, this just lights up more rooms. It was like once I had these things, I suddenly started putting them wherever I could find space for them. And that kind of led to this, which is the original subtitle of my talk was Yak Shaving, or How I Learned to Build PCBs to Control My Home Heating. This board takes an ESP module, a power regulator, and an LED output thing. As you saw from the doorbell, I am terrible at putting things in cases. So what I did was I bought this white case, and then I worked out how to fit a PCB in it that fitted. And then I used KiCad from Debian and built a PCB that I'm sure an electronics engineer is telling you is terrible, but does the job. And then $2, like literally I got 10 of these delivered for $2. Why would I not? And that's actually what's controlling the lights on the top of the wardrobe. There's one of these mounted on the back of the wardrobe, and it takes a 5-volt power connector in and does the Wi-Fi and whatever and connects it out. And this was sort of incredibly easy to do. Again, all within the Debian framework. It was I did it in KiCad, I did the schematic layout in that, I built the files to upload and uploaded to the JLC PCB, and it all just sort of worked, which was really quite nice for someone who is very new to it. And that's kind of what I've got in the way of things currently. I've got some what nexts. I haven't done Zigbee, so if you're familiar with Philips Hue or the IKEA TradFi, there's some wireless buttons around. They use a mesh protocol that's called Zigbee. I've got a module to do this, I just haven't had time to reprogram it with the firmware. Really annoyingly, the tool chain for this is not free. TI have a Zigbee chip, but the library they ship for it only works with the proprietary compiler, so while SDCC, which is in Debian, will compile for the chip, it won't link against the Zigbee bit, so I've been put off a bit by that. I've actually got an external temperature humidity monitor going at the moment, so I've now got one sitting outside the house that's, again, 433 megahertz, it transmits every 1 minute. I've got a receiver that picks it up and adds to the thing. I haven't done energy meter monitoring. My server lives beside the electricity meter. It should be easy enough for me to tie in to that and see the pulses on that and try and work out what's going on. I'm a little bit scared about what it's going to tell me. But anyway, automatic blinds. So the cinema room has Venetian blinds in it. I'd quite like to get something that could then close and open the blinds so that the automation is entirely make the room ready to watch something in and then open the blinds up when they're done. And then this is the one I'm not sure about, the burglar alarm integration. So I have a burglar alarm which has motion sensors and it's got an alarm connected to it, and those motion sensors would be quite useful. But if I get up in the middle of the night and go down and get a glass of water from the kitchen, it'd be nice to turn the lights on for 5 minutes after it sees me thing. But another part of me is like, do I want that in addition to the existing burglar alarm, or do I trust my code enough to replace it entirely and just have it? Probably be better if I could actually monitor and everything, but I just haven't quite made that leap yet. Also, I'm a little bit scared that when I open it to actually hook into the sensors, it's all going to go off, and then I'm going to have to, there'll be a trembler switch in it or something. So I need to do it at some point that my neighbors aren't going to shout too much. So I apparently have 5 minutes left, so I've got time for questions if anyone has any. There's a mic here. I'm obviously not going to run around and do it, but.
Hi, do you have some sort of UPS for this, for all of your devices?
No. Well, yes and no. I have a UPS that isn't plugged in. It wouldn't actually help because I'd need battery backup on all the devices, and the lights aren't going to work when the power isn't on. The heating isn't going to work when the power isn't on. So I think I might get around to doing it for the router and the server that's running Home Assistant, but I would see very little benefit from that because most of the devices that are being controlled wouldn't be operational, wouldn't be useful without enough power. I'd need something more substantial.
Yeah, sure. I wasn't thinking about powering or heating your house off a battery, but I mean, the sensors could still be live, then you would see something going on there if the power dropped.
Yeah, I mean, sure.
Jonathan, do you think about 6-low vapor or wireless LAN?
So there's LoRaN stuff in Belfast. LoRaN seems quite interesting. So for those that don't...
No, I don't mean LoRaN. There's some alternative IP version 6 based low power.
Okay. I think the ESP stack doesn't do IPv6. My home network has IPv6 on it. And my MQTT server is IPv6 enabled, but the devices aren't doing it at the minute. It's a binary stack.
No, you don't need to talk to them to devices by IP version 6. It's just a network based basically on IP version 6, but needs low energy.
Right.
But I can, from your answer, you don't have to use it.
No, because I'm not an electronics engineer, I haven't got into that whole low power stuff. The Bluetooth sensor in the bathroom is the only thing that's sitting on battery only power. All of the ESP modules have mains power attached to them, so a few extra milliamps here and there doesn't matter too much to me, and I know that's a terrible thing to say, but they're all always active on 2.4. The one place it is interesting is I have an external gas meter, and there's no power there, but there's a rotating magnet in it, so there should be the ability to have a Hall effect sensor pick up the rotating magnet, and I'll need that to be low power because it is outside. So I'm going to have to look at that at some point. It's on the list.
Exactly for such use cases where it would be quite useful for such devices. We can talk later.
Sure.
Hello, good afternoon. There are actually two questions. I couldn't understand everything you said, but I believe I heard you said there were no free firmware alternatives for lights, right? I've been reading in the last days, and I've seen Spurna and AI Light. They work with ASP8266. Aren't they then free? For which reason? If you said sorry, if you can repeat, I will be pleased.
Sorry, I do talk quite fast on occasion. So the firmware that sits above, the Spurna firmware and the Sonoff Tasmata firmware I mentioned, are both 3 sets of firmware. The problem is that the SDK underneath it that comes from Espressive, who make the ESP8266, has binary blobs in it. So you're compiling a firmware that is free on top, but has these binary blobs pulled into it, in particular for the Wi-Fi module. So there is a project that can do entirely free, run from the ground up, but doesn't do the Wi-Fi. So that's the problem. The stuff on top, you're right, are available as free firmwares, but you're always building it against a binary blob.
Okay. The second is, have you heard about the Raspberry? Raspberry, it's a voice assistant that works with Home Assistant, and it's quite free and offline. Can work offline. It's
no, I've seen a project that tries to do a free and open version of it, but is always going to the cloud. So I haven't seen the locally non-offline version. So that's cool. It's on my to-do list, but it's a lengthy list.
Thank you. Time's up.
Thank you.